Looking at enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. Previously, we looked at an enhancement for the enemy encoder where instead of using Python always as the header, the encoder picks up one header from a list. And we saw how we could still break that code by just making sure that our code, instead of looking for Python per se, looks for a header that is part of the list. And that's quite interesting. Um, the way we did that is basically we know where in the message we are expecting this header. So instead of looking for, let's say, Python or a specific string, we just made sure it's part of the header list. And then obviously, header length could be whatever, but we assume they're all equal length. And then we could look at the secret message as well. So this was nice, but unfortunately, this solution is not very general. This won't work, for example, when the headers are not of the same length, because then I cannot use header length as a common parameter across all the headers. In fact, we have to do it for every individual header. The other place where this will fail is that in case the header is not placed in the right in the beginning, because then I cannot use 0 as the starting point for the slicing. So, it's good. It's interesting to look at a more general solution, and it turns out that, a better solution comes out, a more flexible solution comes out if we think of using, let's say, the find method inside a loop. Now, the idea here is that we are going to run a for loop over the list of headers, which is known to us. So there could be as many headers. We are going to just run a for loop. Instead of doing slicing message starting at a given start point, we are going to use the string.find method to determine whether the header is inside the message and if it is there, then where does the header start? So that makes it very general. Of course, it comes with some complications as well, as we'll see later. And since we are iterating over the list of headers, we can find out the length of every individual header. So, the code becomes quite nice and quite general. What we are going to do, like I said, we are going to run a for loop over the header list. Now, in this case, we are going to find out if the header is found inside the message at position 0, because right now I'm still solving this. I'm still assuming that, the header is placed in the beginning. But once the header has been found, I can look at the length of the header and find out where the, let's say the message is. To sort of facilitate all this, I create a Boolean variable called code broken, and I set it to false. The whole idea of this code broken is that if I found the header, then I don't need to look for other headers. Remember, this is a for loop over the header list. Once a specific header has been found, I set this to true, which means the code has been broken. I also add a break here because I don't need to search for other headers. Of course, if code broken is true, then I can break off from the original search as well, because this particular shift in the Caesar cipher has given me a header which worked for me. So notice there are two breaks over here, but the role is very interesting, very clear. This break here breaks you from the inner loop, which is searching over the other headers. This break here breaks you from the outer loop, which is searching for the different shifts in the Caesar cipher. So be very clear on this. Now let's see this working in the code, and then that becomes more interesting. So like I said, I'm going to start with with a Boolean variable called code broken, and I set it to say false to start with. Now I will just do this first for the message decode, which means that's basically saying encoder is 0. And once that is done, we can see, it can be quite easily extended. In fact, so I'm just going to say for header, for example, in headers, say list, basically iterating over all entire header list, I just find out if msg, let's say msg decode dot find hdr is equal to 0. Now remember, find method tells us where this particular string is found inside the big string. So if I find the header at the 0th position, that means I have found the header. In fact, it's exactly what I was doing earlier in a way. So I just say, for example, say header found, and let me just also say print the header over here so that we know what is the header we are looking at. Then I can print, for example, let's say, secret code, say code is, and you can just bring in this line. And in here, this has to be message underscore dec, and here I will use length of header instead of a fixed variable. So let's say length of hdr, and go until length of header, say plus 10, because I know that the message is 10 characters. So I do the slicing, from length of header to length of header plus 10. And of course, once this happens, I say code broken is equal to true. and I can then break off from the inner loop, right? So if I break off from the inner loop, because I do not need to search for other headers. Now, once this has happened, I can also break off from the other, from the search itself. So I say if code broken, say code broken, then I can just say, okay, I need to colon over here. I can say break. Now remember, as I told you, this break is for the inner for loop, which is basically searching for all the headers. This break, on the other hand, is for the outer for loop, which is searching for different shifts inside the Caesar cipher. Now, let me for now, just let's say comment out all of this. I just use, let's say, block comment to just remove some of this, and all the way until, let's say, here, right? So this part has been taken out. Now, just to test this code, I'm going to, for now, just set the encoder to say only 0, because that's the only one I'm looking at right now. If I did this, notice my message sent was cobras something. I heard something else. I figured out my cobras is the header, and indeed this was a secret code which I managed to find exactly like earlier. It's not a surprise, because we really not, really the same code expressed a little bit differently. Once again, it happens to be cobras. Let's say this time the message is Python with this as the secret code, and indeed I find. Now, the reason this is working is because if I look at MSG decode, it's whatever it is. So if I look at MSG decode dot say, let's say find, say headers list, say for example 0, that gives me a 0, because headers list 0 is Python, and indeed because Python is found inside this. On the other hand, if I were to look at, let's say, headers list 1, it gives me -1, because for example, headers 1 is snakes. I do not find snakes in there, or say cobras, I won't find it. So I can look same way for the headers list 2. So I don't find it here, right? Now, in order to make this, let's say, more works for all the encoders, I will have to repeat this piece of code, but that is quite a repetitive process, because the same piece of code has to work now on message decode EO, message decode R, message decode MS, and so on and so forth. It is more efficient for me to define a function. So that's what I'll do. I will say, okay, look, let me just, put all this here in a function, because then the code becomes cleaner to write and it's easier to understand what's going on. So I take this, let's say piece of code here, and I say, look, I am going to write this as a function. I'm going to fix the indentations here. So I'll just say, let's say def find, let's say header, and let's say I'll pass this input and I call it a message. Now this message, please do not get confused. This message has to be seen as a local variable inside this. If it's confusing you, you can just say message function, let's say message fun, so that it's clear that this message has got nothing to do with the other variable message, because whatever we are defining in a function is completely local to the function. But nonetheless, let's call it message func. I say, okay, for header, in headers list, if message underscore fun, you know, dot find header is equal to 0, well, I can say header has been found. The secret code is whatever it is, say message fun, and that's about it. In fact, I would not want to print it from here. I can just return say a secret code is equal to, let's say, this. I can remove this print as well, and I can set my code broken to true. But before the, when the function starts, I'm going to set my code, code broken to say false, and I'm also going to set my secret code to say an empty string. Right now, because the reason I do this is because I'm going to return these two parameters from the function. So I come in here and I just say return, for example, code broken, say code broken, and say secret code. So I return these two from the function. Now be very, very clear that the names of variables, whatever is inside the function, are completely local, which means I can reuse these names outside the function and there'll be no interference, right? So what I will do is that I'll say, okay, look, I'm going to say code broken and say, secret code is equal to say find header, and here I'll just call it, let's say msgdc. So basically first I send the message decode to see if I can find the header. Remember, if the header is found, my code broken is going to come back true. So if that happens, I break from this loop, I break from the shifting loop, and now all I need to do really, and in fact I can print my, let's say I can print say the secret code, secret code is, and so My secret code is, let's say, secret say code. And all I really need to do now is to just run this for all the four messages. So I take this and I duplicate, four times. This time round, of course, I'm going to do this for message decode, let's say even odd. Um, I'm going to next do it for, let's say, message decode reverse. And finally, I'm going to do it for, let's say, message decode MS. So this has to be for message decode, let's say, R. And then this has to be for message decode MS. Now notice this code has become a lot more concise, and it's more easier to read. We kind of understand what's going on. That first I try message decode, I see if I can find the header in there at the right position. If I find it, I break my code, I tell my secret, I sort of say, okay, I've broken the code, and I get out of the shifting loop. If that doesn't succeed, I try the message even odd. If that doesn't succeed, I try the message reverse, and finally I tried message middle swap. One of these has to give me the right answer, and just like earlier, wherever I get the answer, I break out of the shifting because indeed the code has been broken. Now, another thing which is interesting here is to note that I'm returning two values from this function. And the usage is very simple. I just say return this, and basically I'm assigning them to two variables here in the same order. Again, like I said, these variables inside function are local, which means I can use the names again. The context is totally different, right? Now, see this working. It's quite interesting. Before that, however, let me set the encoder to, let's say, not to be 0, but encoder could be anything. So enemy is back to its, let's say, its ways doing whatever. Now, notice here the snake, message was snake something. So the header was snakes. Secret code was, let's say, this. Indeed, my code found it. Snakes was the message, and the secret code is this. We can check what the encoder was here. Encoder happened to be 1. So what we were looking at is message decode EO. And if I see that message decode EO, indeed I see the header is present over here. On the other hand, if I were to look at, for example, message decode, I won't find my header in there, right? And that's, we can just see one more example. So this time round, let's say I take encoder. So encoder is 2, and indeed my message was, say, tvx whatever, and that's exactly what I have here. Message being 2, it means that I was looking at message, decode, say, R, indeed correct, and I see a Python over here. So basically what happened right now in this code was that, I tried, let's say it's here. So I tried, finding the header with the decoded message, then the even odd swap, then the reverse. Here I found success. I broke off, and my KK is, say, 2. So quite early. But it basically went through went to the shift of 1, tried even message decode, even odd, reverse, and so on and so forth, right? We can, in fact, just for the sake of completion, I'll just force my encoder to 3 and make sure that's also working, right? So that's a good way to test. I set my encoder to 3. If I did this, so notice again, I'm hearing whatever I'm hearing. My message, my secret code is EIZ, as you can see here, right? So this also works, but of course I should remove this. This was just for testing. So I hope you found this interesting. The way we have organized the code is quite interesting over here, because it avoids excessive code, makes it more concise, and makes it more easy to read. In general, if you think that this way of learning works for you, it's fun, look at our website, because there are many such activities. Take care. Thank you so much. Bye bye.